afternoon. My name is Liz Pierce, and it is my pleasure this week to introduce Dr. Hong Chin as our guest speaker for our Integrating Bioinformatics Education series. Dr. Hong Chin is an associate professor in the Department of Computer Science and Engineering, who uses computational and mathematical approaches to investigate biomedical and biological questions. Dr. Chin is a recipient of an NSF Career Award from 2015 to 2020. His expertise is in graph reliability modeling, bioinformatics, computational genomics, mathematical modeling, systems biology, cellular aging, and gene network analysis and modeling. And I should mention that he is faculty at the University of Tennessee at Chattanooga. Today, Dr. Chin will present how to use R to analyze COVID-19 data. He has prepared a very nice tutorial for us for learning R to analyze COVID using the Google CoLab cloud, so no local installation is needed. So I want to thank Dr. Chin for joining us today and say we look forward to hearing your talk.
Thank you for the introduction. So I put a link on the chat window. Actually, not me. Dr. Elizabeth Pierce put a link in the chat window. That's actually, if you click that chat window, should take you to this public GitHub repository, and there's a code called learn R, UALR. Underscore collab.ipynb file. So if you can see my mouse, I'm also clicking an icon, say open in CoLab. So if you click that icon, it's going to take you directly into CoLab. Once you clone that into CoLab, you actually need to save a copy of that into your own CoLab account if you want to modify it. Otherwise, it's going to just, it's because it comes from my GitHub account, you cannot modify it, or might have trouble to modify it. So if you have a GitHub, the CoLab account, and usually you can just log in using your university Gmail account. So while you are doing that, I'm also going to explain a little bit about the CoLab environment. So CoLab, if you see what I'm highlighting, what I'm circling with my mouse is also there a plus code. If you hop your mouse on there, you can see it says insert code cell below, and then there's a plus text that says insert text cell below. So the CoLab has two kind of cell. One other cell is this kind of a shaded gray. That will be the actual R code. And next to the code cell is the play icon. If you recall on your cell phone, if you want to play music, with this play button, that's similar. So if you click that, that's actually run some R code. In this case, I just run +4, which is a 6, pi 3.1419159 something, log 10 pi. That's take the log 10 result of the pi. So that's a few basic R code run in CoLab. There's also the text file. That's just a way we can provide some documentation for R code. So, very good. Can we move forward now? But on the CoLab, you can also, sorry, a question?
I think we are good. I just want to let you know I've actually tried out the instructions and it's working fine on my machine.
Okay, good. Yeah. So on the CoLab, there's also a table of content on the left-hand side. In fact, there's an icon there, almost like a bulletin point with something, table of content. And there's also a menu at the top. The file editor, the runtime menu is probably the most useful. In fact, you can run the entire code, say run all, just to see what happened. If you can click run all, and the entire code runs, that means it's quite everything is working fine on your side. And if you can run all, you can also modify the code to see to explore how. I think some people said the best thing to learn how things work to break it first. So yeah, so feel free to modify the code and run it. And Google CoLab is also run everything in the cloud. It's not making any change to your own local computer. So, okay, so that's the get familiar. So here on the CoLab, get familiar with the CoLab. I can also minimize that section using this arrow next to the table of content at the header. And then there are some warm-up exercise. So R can be used as a simple calculator, like 2 plus 4, and then 2 times 4, and then 9 minus 3, 9 divided by 3, 9 minus 7. So there we have what? 8, 3, and 2. And we can also look for help information in R. And that's actually just a question mark with some command we want to look for. So question mark R norm is actually means random number generator using a normal distribution. So by default, it's also with a mean of 0, standard deviation of 1. And you can actually specify that. So by definition, the R command is using the smooth parentheses to indicate the function and how you assign a parameter. Another common R function is probably linear model, a linear regression model. Another function called the AB line is plot a line with A as the slope, B as the intercept. I'm sorry, I said it wrong. A is the intercept, B is the slope, so AB line. So in R, we can also generate a vector or a list of numbers. So here the syntax is with a C parenthesis and then put some number there. So 1, 3.14, 5.0, minus 110. So the vector is there. And then we can have a B vector. In this case, I just specify, say, A vector plus another vector. So there we have the B vector. All right. If we have the vector, we can also index it. So if A and B are just two vectors, A is the 4 to 20. That's actually a sequence, using a sequence to generate a vector. So and then we can actually indexing them. So if I want to say the first element of A is 4, right? So if I say fifth element, that's 8. 1, 2, 3, 4, 5. Yeah, number 5 is 8. So, and the next example, I randomly generate a normal distributed random variable of x as the vector, and y is just a linear transformation of x plus some random noise. So, yeah, so y is a linear transformation of x with some Gaussian noise. Basically, a Gaussian random number, very small, I divide. Times 110 is actually not very small noise, a very large noise. And then do a linear regression y over x and plot x over y, and then added this regression line a over b. Sorry, regression line of y over x using an AB line plot. So there, that's the scatter plot of x and y with a linear regression. So in this case, we can also see the linear regression result, see whether it is significant or not. It's probably highly significant. But actually, yeah, it's moderately significant with a p-value 0.016. It's a linear transformation, but I added a lot of noise there. So yeah, so R is a very convenient way to do some statistical and numerical calculation. So indexing our vector usually by square bracket. In fact, we can even using a vector to indexing it. Another important concept of R is something called data frame. It's just like a spreadsheet in Excel. So since we have the X and Y, we can combine them, put in the spreadsheet. So this will be a spreadsheet of a 2 column with X and Y as the 2 columns. And then we can index this the 2 columns using the square bracket, row number, comma, and column number. So if I say table square bracket 1, comma, that's the first row. Can double check that is the first row. That's good. And we can also take the second column. In this case, minus 5.34. Yes, the first one minus 3.4. Second one minus 16 something. Yeah, so that's correct. Yeah. So that's how we indexing rows and columns in a table. We can even indexing a selected column 1 to 2, selected rows 1 to 5. That's how we do that. And we can even say indexing rows, say 1, 5. Oops, I typed it wrong. 5, 9, 1. Right. Yeah, so that's the 5th row, 9th row, and 1st row, and then 2 columns there. So, okay, the R is very popular because hundreds, if not thousands, of the packages are available. Those are people around the globe, around the world, contribute to the open source package and do a lot of work for us. So one of the most popular packages is called Tidyverse. And there are also some other lubricant reshape. I just put it there. So if you run those, it's going to install the reshape library and some Tidyverse library. We have to install the reshape library on CoLab because by default CoLab does not store that library. So we have to install the reshape 2 library if we want to use that in the CoLab. Generally, just call the library. If CoLab doesn't have it, we install it. That's the way CoLab. It's free, but it doesn't have the full feature yet. So once we have those Tidyverse library, we have the data frame, we can now do a plot. And the ggplot is actually much more powerful than the basic plot I showed. In the basic R plot, those are basic plotting function. But in the ggplot, you may want to do more study on your own. In fact, Data Camp is actually one of the best source to learn these things. ggplot has a different syntax. It's something called almost like 3D printing. It's additive plot. So you specify a plotted product, then you add another feature. In this case, that's a scatter plot, and then add a smoothing function. So if I break this one down, step by step, so I'm going to say first do a ggplot using the table I just defined with a static, which is x value the horizontal x and y value of the vertical x. I run this. Now I just got a blank plot. But then I can tell it, oh, now I'm going to add the scatter plot. Your point. Now I have a y and x scatter plot. And then we can add some smoothing lines. Smooth. There, then they draw a smoothing trend. So it's actually a very nice plotting function and the data bundling package. So that's the tidyverse. So we can also change the smoothing into a more detail. In this case, if we use the stat smooth with the which is the smaller span, then we can have a more detailed smoothing, and it's kind of empirical how bigger the range of smoothing you want for some the specific data project. And in general, we can also read the spreadsheet from the website directly. For example, here, I read a spreadsheet as some people's grade there, and these are some very good students. Apparently, George Washington, John Allen, so Millard Fillmore, 100 point. First of all, here, this is a OK student, got a 78. So, but then we can actually index in this column. So this table with a grade. So if I just table $, that's actually take the column, that's grade column. If I say also table bracket number 2, it's also the first column is the name, the second column is the grade. So that's also the second column. And pick the row, the first row. Yeah. So that's actually just some exercise of the do a data frame manipulation. So, okay, so that's probably a very brief introduction into our tidyverse unplot. So now let's start with the COVID-19 data analysis. If you look at the table of content, this is my goal is finish part 1, part 2, part 3, and maybe part 4 if we have time. So let's first start with part 1. So the COVID-19 data set, probably the most popular one, COVID-19, is from Johns Hopkins. It's actually a public available data set on GitHub. It is this set, COVID-19 data repository by the Center for System Science and Engineering at Johns Hopkins University. So in that public repository, there is a directory called CSSE underscore COVID-19 data. And in that directory, there is a time series report. And in that directory, then we have the time series of COVID-19 deaths by US, COVID-19 confirmed by US. So this is the data we are going to analyze. Time series COVID-19 confirmed US CSV. So I actually link that directly right here. So I'm going to read directly from that from this public GitHub repository into the CoLab. So that's how the cell I'm highlighting. If we click run the display button, there it's done. So now we read that that's US confirmed case into a data frame called TB table. And if you look at this table, it had many columns. UID, ISO, I have no idea what those is, by the way. But some information seems to be self-explanatory. For example, admin 2, here we have something Baldwin, Alabama. That looks like a county name, and province underscore state. That's the state in the U.S. Country, U.S. Then latitude, longitude, and then there are dates, which with a case number there. So it seems to be a self-explanatory. So I'm going to again pick some rows and columns and see whether we can manipulate this data set. So now I pick what? The first row, second column. First row, second column is what? First row, second column, US, so that is the US. Fourth column, fourth row, fifth column, that 107. Fourth row, 1, 2, 3, 4. Fifth column, 1, 2, 3, 4, 5. Yes, 1007. Apparently, BIP Alabama has a code FIPS of 1007. So that's how we get the. So now we know we have the data, and we can also pick the first 10 rows of the first column, or the 7 to 7th rows from the column 4 to 8. And we can also look at the columns. We realize the actual case data actually start from the 12th column. So from the 1st to 11th column, those are all kind of meta information. It looks like they are tell where the data are collected from. In this case, that will be county, state, US, latitude, longitude. So you look at that combined T, it represents a unique location. In fact, we can actually use a R command called length to find out how many columns are there. Well, there are 279 columns of data, so it's actually kind of difficult to analyze this data using spreadsheet. It will be much easier to actually write a scripting language like R code to analyze this. But then we know the first 11 columns are not data, so we actually need to pick just the actual data, the case number to analyze. So actual case is from the 12th column to the last one. The last one is basically the length of the row. So that's how we pick the entire data set for the first 5 columns. So if we scroll all the way to the right, you see we have data now. October 15 is today. What's today's date? 16. So that's from yesterday. And the starting point is January 22nd for every state. Obviously, every state has their own starting point, but that's how this table is organized. So, very good. So, okay. So what I'm going to do now is everything. So if you look at it, we probably are interested in how the case for each location, but each location is in a row. That's actually not very convenient. In many Excel data sheets, each column is something is easy to analyze. So what I need to do is pick all the columns and then make all the columns, pick all the rows, make all the columns become rows. Actually, that's in linear algebra, that's called transpose. So we have to change all the rows into columns. So we first pick all the data. This is actually in tidyverse, something called select all the columns. So I select a column from number 12 to the last one. If we run that, you can see those are actually quite a lot. Those are all the data columns. After we select, we can also using the left-hand arrow assigned to a different variable to be assigned to a different table. Let's call that table 1. And then I'm going to transpose. T is for transpose. T for transpose. And then I transpose that table and then make sure it is still a data frame. And then let's look at this data set. There. So now we have the dates of the rows and the numbers cases now as column. Actually, probably easier if I look at the tail. Oh, I missed the parentheses. Okay, so now this is like to look at it. So see here, the first column, October 15, we have 1949. October 14, we have 1928. So there, that's this county. And it's actually, but now you see the column name are not really meaningful. 1, 2, V1, V2, value 1, value 2. I want to use the location as a column name. So I want to use a combined key as the location. And basically, I rename this table with their location. So now I know the. I'm going to look at the last part because the first mostly are 0. So the tail. Yeah. So now we see the first location, Altaga, Alabama, something case 53, 58. Yeah. Now it actually look more intuitive. So we have the each location in a column, each row is a date, and this is obviously a very large spreadsheet again. Now, this date information in the column name is actually not a value. I need to convert that into an actual value, a date type in R. So that actually is done by the package called LubraDate. So we first make sure the LubraDate is there. You can actually see if I say date string, that's actually is the word of date. And then I'm converting the data type called date type, which is time, October 1st, 2020. So we can also look at the current date. The current date basically are the names of those original column names. And those are all string. They are inside the string. But if I convert that into by month, date, and year, and then this is actually become the actual date type. So I can just then convert all those date into the month by month, date, and year, and then assign it into a column called dates. So now if I look at this table again, if I scroll all the way to the right, you will see a column of dates there. On January 22nd, is that correct? Yeah, January 22nd, the second one, last row, January 27th. Yeah, January 27th. So now we have the actual date. Actually, if we look at the tail, maybe it's more informative. Yeah, October 15, October 15. Yeah, so now we have the case number, we have the dates. And we can also select a window. Since there are so many 0 there, we don't want to look at the window. Let's start with the May 5th instead of the January 22nd, since especially in the southern states, many of the cases are 0. So if I pick the May 1st, so now you see now it's not 0 anymore. It looks like May 1st is actually not a good idea. Maybe April 30th, then May 1st will be there. So okay, then May 1st is there. So 42, 45, yeah. So those numbers are there. So there are still some 0 there. But let's move on. So if I want to do a time window, I can just pick a time window like this. Starting date from the start to the end. In this case, it's just 1 week, 14 days window. So, and we can now actually do the plot. If you recall, for the COVID-19 data analysis, you probably want to see what's the trend, right? Say in the last month, how the cases has been developing. You want to plot in a time window. And for this example, I'm using a 14-day time window from September 16 up to 14 days, see how it look like. So we have this a 2-week time window, and then we're again using ggplot. Okay, so this is ggplot for the third column, which is third column is what? Barber, Alabama. That's the third column of Barber, Alabama. So what if I want to look for a specific county? I want to say, I want to look for Pulaski. And, well, okay, nothing happened. There are actually 7 there are actually 7 Pulaski counties in the United States. Not sure why this one doesn't print. I'm going to ignore that. Apparently, there's a funny error there. There are 7 counties in the United States. So 7 Pulaski County in the United States, but we want to pick Pulaski from Arkansas and for this analysis. So I'm going to pick Pulaski. So let's see, Pulaski, Arkansas, US for the analysis. So let's call that. I'm going to pick that one and call it TB_my county. So here. So now we only have the data from the Pulaski, Arkansas, US, dates from April 1st, from April 1st to October 10. So, and then we can now do a plot. Again, wow, it looks like almost linear going up. So this is what they call cumulative cases, right? So, and we can also compare Pulaski with other counties, right? It's always fun to compare ourselves to some other people to see how we are doing. Yeah. So, well, there are 70. There are 77 counties in Arkansas. I'm not sure, but that's what the data here. I actually I hope that's correct, more or less. So we are going to how do we? So I'm going to compare Pulaski, Arkansas, with Hamilton, Tennessee. That's where I'm at now. And Davidson, Tennessee. That's actually from Nashville. That's actually one of the worst places at Tennessee. So I picked that, and let's put the last day is again October 10. I'm going to pick 100-day window. Time window is a 100 days time window. So, okay, so now we have Pulaski, Arkansas, Hamilton, Tennessee, Davidson, Tennessee. I guess 100 days started in July 2nd. Huh. That's interesting. That actually means 4th of July will be covered. So then let's plot all of them together. And the way for the R Teddyverse to plot them, we first need to convert them into one data frame with just 2 rows. So that's actually something called melt. For the time being, you can just run the code and get the data. What this means is it's going to put all the cases in one column and put all those locations in another column. And then when we just plotted the scatter plot of the 2 columns, but we use different color to represent different location. So that's actually explained the following line. So we plot that converted data frame underscore TMP, temporary data, with the days as the horizontal axis, and Y, which is a daily days is there. Y is the daily cases. And then I'm going to label all the counties by different colors. And then we can compare the 3 counties. So, so now we have the red is the Pulaski, Arkansas. Green is Hamilton, Tennessee. They're actually quite similar. And then there's the blue, oh, that's Davidson, Tennessee. That seems to be a much higher. So, questions? Oh, questions.
Yes, we had one question. Kim would like to know, there are alternate services to Google Colab like MS Azure Notebooks and CoCount. So she was wondering if you had tried some of these other platforms, and if so, could you tell how they compare with each other?
I have not tried Microsoft Azure or other things. Yeah. So I don't know. Yeah, sorry. Yeah, I'm using CoLab. Also, I guess I'm familiar with it, so I'm not. Yeah. Microsoft, IBM, Amazon, Google, they all have their own different platform. You can try many things. I have not. Yeah. So I maybe someone could dig into it and do some comparison. I guess. Yeah. But I used to use Amazon AWS. That is actually quite a cumbersome, and what's worse, I also need to pay it. I don't want to pay it. And Google Colab is free, so yeah, I don't use AWS anymore. Microsoft Azure I have not tried. Yeah, so good question. So let's say the Google Colab is free, so it's kind of a bit slow sometimes. But there's also a paid version called Google Cloud Computing (GCP). And that actually can be faster, but then you really need to pay for it. For education, you probably get something free too. Yeah. So, by now, what we have is cumulative cases. That's actually not very informative because in many cases we want to know how every day what's the number of new cases, right? So we can also do a daily, try to convert the daily cases. So in this case, I'm going to read the data again. Then I'm going to convert the cumulative counts, daily counts into daily cases. And that actually can be done by something, a function in R called differ, D-I-F-F. That's actually a Unix command. For those who are really into it, why it's called differ. But we can apply the differ command and convert all the cumulative cases into daily cases. I calculate the difference between rows. So there. And then we have the daily cases. And let's just do some manual check. And then if we plot the daily cases, that probably will be more informative. So in this case, we pick the Pulaski again, and we're going to do this is Pulaski, Arkansas. So there, that's the daily case of the Pulaski, Arkansas. France. When did we start? April 20 to, it looked like last week, October 10th. Oh, it's actually we plotted to October 15th. That's just yesterday. Wow. So it's clearly increasing then. Yeah. It looked like it actually goes down in the summer. Peaked sometime after 4th of July. And then has been going down. But it looked like since September it had been increasing, generally increasing. So okay, so and that's the COVID-19 cases of Pulaski, Kansas. And you probably heard one of the best way to prevent COVID-19 spread is social distancing. And the one way to measure social distancing is using mobility report. And we can actually using the Google Mobility to approximate this. So Google Mobility is also public available. So we can actually run this command, wget command on CoLab, and then it actually will download the Google Mobility data directly into the CoLab directory. So that's actually there. And then we can also unzip, because the download file is a zip file, we can unzip it. Once you unzip, you actually found out there are actually a lot of a file because of all the regions. So you can actually find the US regional report there, and then copy that file path in this case, I know the file path is there, and then we can read that the US regional mobility report into R. In this case, I call the TBGM Google Mobility US. So that's the table of Google Mobility for the US regional report. So now we have the, if we look at this table, we'll see the country is all US, and then sub-region, that's a state, sub-region 2, county, and then we have dates, and then we have a retail, percentage change from baseline grocery, and then what's that, residential and workplace. So Google Mobility had some very long names. So, but let's just pick the sub-region, which is Arkansas and Pulaski County. So and let's call that table Google Mobility My County, and in this case we have it only for Arkansas Pulaski. And mobility actually apparently Google started it from April 15, and it's actually Google Mobility that updated weekly, so it's actually not very recent. So if we look at the tail, the most recent one, let's look at the tail. It goes way to, oh, it actually goes to the October 13. It's actually 2 days ago now. Yesterday I checked, it's still October 9, which is last Friday. So, but it's not most recent. So we have still have a 1 day or 2 day lag, sometimes even a week. So in this case, let's see, it goes to October 13. So remember the mobility, the COVID-19, oh, we don't have the weather at the bottom. So the COVID-19 set is actually from yesterday. So if we merge the two items, some days will be missing. Another question? Oh, yeah. Yes. Question?
No question. I was just posting a comment for folks who are interested in finding out more about the CoLab resource limits. I posted the page online.
I see. Thank you. So let's see. So to merge the in this let me go back to a table of content. So right now I'm in part 3, Google Mobility Analysis. So I now want to merge the Google Mobility and COVID-19 cases for Pulaski, Arkansas. So I first need to make sure the dates are matching, right? So because the COVID-19 data has different date range compared to the Google Mobility. So what I do is first check the dates, make sure the dates can be matched. And, in this case, let's see, Pulaski. I'm also going to remove the Davidson County, since we are going to just focusing on the Pulaski County. And then we're trying to find out share the time window between the COVID-19 daily cases and Google Mobility. So in this case, the daily cases start from April 22nd. And ended yesterday. The Google actually ended October 13. So we will use October 13 as the last date. Otherwise, the Google Mobility will have missing data. So the first date actually we can, both of them have the April 20, the starting date. That's also okay. So so I'm going to start from April 20 to the October 13 and then merge these two data sets. So there. So I'm going to first train the Google mobility into that beginning and end date. And train the Google mobility, I'm going to call that TB my county, my county 2. I think I have a typo there. My county 2, sorry. So this table now have 177 rows and 7 columns. And then I'm going to train the COVID-19 cases also into the same time frame. So this one also have 177 rows and 2 variables. And I can also check whether the data are matching or not. In fact, they are 100% matching, so that's good. So now we can go ahead and merge these 2 data sets. If this is a spreadsheet, you have 2 data in the 2 spreadsheet. You can cut one spreadsheet and paste into another. And we basically do the same thing in R, but instead of a cut paste, we call it the column bind, C bind. Combine the COVID-19 cases with Google mobility data cases. Combine them and make sure the whole spreadsheet is still data frame, and then check it. So there. So we have the daily cases. There are 2 data columns because both data had the dates. And then we have the Google mobility. So I'm going to remove that redundant date. Just the none column, but I'm going to remove the redundant date and only pick the actual values. There. So I remove the date. And remember those dates, you see there are a few numbers, they are minus something. So if we plot this number directly on a plot, the number will all over the place. If I want to overlay them, I want to normalize all the data into the same range and then plot them. So what I do is I normalize the data first, and that's actually, there's a very simple function called scale. You just scale the whole thing, and between the that's actually scored to a normal distribution. So with the average at 0. So there we have the normal distribution there, and then we added the date back into the data frame with the date now at the right hand side, and then we can overlay the mobility and the daily cases for Pulaski, Arkansas. So, and that's just to double check the column names. And in this case, we are going to overlay daily case and the work and the residential mobility score. So, so now we have the red is the daily cases change. The good, it looks like seem to be plateaued a little bit recently. And we can see the workplace mobility. Oh, I guess after September, the business start to reopening more often. So it's workplace mobility increase. The residential mobility decrease. That seems to make sense. People now come back to work, so the residential mobility goes down. Workplace mobility increase. So, but coincidentally, the cases also increases. So. Okay, so that's actually a summary to look at normalize the data. We can skip that for now. Okay, it looked like we actually I have another 10 minutes or so to go over the weather report. So obviously the weather is fall, the winter is coming. So it probably will very interesting to correlate to see how the weather has changed the mobility and COVID-19 cases. Let's hope this works. In R, there is a package called WorldMat, which will retrieve the real-time weather data from the airport around the country. So you need to first install that package first. That actually take a few minutes because that package actually need to install a lot more package. But I already installed it. So once you install that package, you can actually found out that the airport in Arkansas, apparently in this, there are two airports in Arkansas provide the real-time weather data. Arkansas International Airport and Northwest Arkansas Regional Airport. In fact, that's the another way. Oh, that's not Chattanooga anymore. That's the Pulaski, Arkansas. Another way, just by latitude and longitude. That's the Pulaski, Arkansas, the latitude, longitude. Oh, wait, Arkansas is the AR? Sorry. Arkansas. And then another way is just to get the airport by latitude and longitude. So, the way the weather will be retrieved is based on the unique airport code, which is a combination of the USF code and W bank code. So I'm going to just pick the first one, Adams Field Airport. Then use that code. That will be what? That number 727403 and dash 13963. And we are going to use that weather data to represent Pulaski, Arkansas. So, yeah, so those are the hourly weather report from this Little Rock Airport, Adams Field Airport. And it actually has the date, time, and hour, latitude, longitude, elevation, air temperature, pressure. In fact, there's a lot more. What I'm going to use, just to use a few something I know. For example, like the air temperature, dew point, relative humidity. Those are kind of intuitive. So, and we can again use a ggplot to plot, in this case, the dew point. We probably can just the next one. This is the air temperature. So, I guess Pulaski is getting cold. Those are Celsius, so that's yeah, it's getting a little chilly. So, and the humidity also goes down. Relative humidity probably also goes down. So, and then we can reformat the data, try to overlay with the COVID-19 cases. So so let's just run the loop date. So that's the date and the weather temperature, weather humidity, and dew point. So, and then I'm going to merge the weather data with the COVID-19. So merge by the date, and then plot them. So plot from the starting date to the most recent date. Let's see. That's interesting, isn't it? So now we have the temperature. The temperature actually temperature is here. Well, you can see when temperature start to going down in about the first week of July. The case has been increasing since later August. But it's actually, if you look at the temperature, it's not always negative correlation, but it's also positive. Apparently, the middle of July, both temperature and the cases hit the peak. But now temperature has been going down. The cases actually exceed the summer peak now. So, and I think that's what I have for now. Yeah, that's what I have now. That's actually that. So we can actually do a lot more. We can actually now overlay mobility with the temperature, see whether the temperature and mobility correlate. We can do some cross correlation analysis. In fact, you can do this for the statewide. You can do transmission analysis, and you can also compare the county separated into, I don't know, Democrat governor or Republican governor, and do a comparison between the red and the blue state. You can do any analysis once you have this data. Yeah. So I think that's about what I have. The questions. Let me just start. This must be a very fast pace to go over this. Yeah. Let me just stop here and answer your questions. So.
Well, thank you very much. That was really interesting. And I can just see how you can start digging deeper into the correlations to try to understand what's happening to people and their mobility as the weather changes and then the changes in COVID. I want to thank you very much. That was a great survey of what you can do with R and CoLab and data. I was wondering, my question is, in your experiences in teaching R, what are your preferences, particularly when it's teaching maybe non-computing majors? Do you like to use a dedicated course for getting students up to speed with R? Or at your school, do you try to teach it as part of another course where it's sort of embedded in a course?
It's always embedded. We do not have a separate programming language for non-computer science. In fact, for R, we never have a specific case just to teach R. It's always our course is always the generic, and basically any language that goes with the course description. So R is. I also almost never teach R alone. I always, at least in so-called data science, I have been teaching both Python and R in the same course. Depending on the situation, we use different language.
Thank you very much. Let me see, are there any questions from the audience? One other question is, yes, so with CoLab, I'm just curious, how do you switch between languages in terms of switching from, let's say, a Python notebook to an R notebook?
Oh, that's something. If you click, wrong time, change wrong type. You can switch between Python and R. You can even choose between a GPU or a CPU. So yeah, it's actually quite convenient. Now the tricky part, they cannot mix R and Python at this time. So if you already have R code, you switch to Python, you seem to be confused. You have to either use Python or R for one specific code. So. The nice thing of CoLab is every student will have the same environment. So that's the nice feature. So at least for the hands-on analysis, it's quite convenient. So yeah. And it's also built in with GitHub. This is I really like. So I finished it and corrected. I just updated to my GitHub account, and actually the code is now updated now. Oops, oh I closed my R code. So so the GitHub repository now, if you look at my commits, is there. It's updated 2 minutes ago, and so the CoLab and GitHub are integrated. So that's a nice feature. So.
We have another question. Kim would like to know does this platform support the majority of modules and libraries in R? Have you had any dependency issues while using CoLab, or possibly found a package an R package that you couldn't run in CoLab?
Yes, I do. There are some packages I cannot run on CoLab, so we have to run it locally. So the CoLab is useful, but does not support everything right now. In fact, they don't release it public. This is still a beta version, the research version. So this is still a beta version, not really a full-featured R environment. So that's a good question. So in fact, you can also see, even though I'm running R, but the entire code is still called Python, a notebook. It's still called IPYNB. That's a Python notebook. So there are some limitations to run R in CoLab. But if you want to run Python in CoLab, that's actually fully supported. In fact, you can use many of the Python package in CoLab. Is much easier to run than natively than locally. So because it's actually, especially you want to run machine learning and deep learning package, you need to configure your own GPU, make sure the version are match. That's actually quite a lot of headache if you want to set it up locally. On CoLab, that has been taken care of.
Well, thank you very much. I'm just pausing for a moment just to see if we have any. Oh, we do have another question. Actually, this is a question I get a lot too. Is there any reason to prefer R over Python?
R is many of Python is the industrial language. I mean, many industries like Google use Python a lot. R is started as a statistical and numerical language, so there's a lot of academic research has been done in R. So, and for many research, it's actually much easier using R. In Python, we have to even redevelop some very basic functions. But for many industrial purposes like a web development, a database, those kind of things, Python are very good at. It depends on your purpose, right? So my work is mostly academic research, so R is much more convenient. But let's say for people working in industry, Python certainly you don't have to. If it's a research, it probably is not good for business, because business you don't want to do something which is not being a so-called mature technology, I guess. So the industry they probably do very simple analysis, but you want to do data integration, visualization, web delivery, all those other things, right? So R is not good at other things. R is good at the data analysis, mathematical modeling, those kind of. It depends on what you want to do, I guess. Yeah. Which is also the reason I teach both R and Python. I also use R and Python almost on a daily basis, because the TensorFlow is best supported in Python. So we do a lot of machine learning and deep learning using Python. But for many other statistical mathematical work, we still use R. So it's almost like Yeah, one is the truck, one is the race car. You have to use both of them, depend on the situation. So, yeah.